Since we're going to talk about different types of functions, we need to go back to the definition of what a function is and a relation. So a relation is like a relationship or any set of ordered pairs, x and a y. So you can list the ordered pairs, you can have a graph of ordered pairs, you can have a table of ordered pairs, you can have a mapping, which is down here, which we're going to do. So a relation is just a general set of ordered pairs. A function is a special type of relation where every input has exactly one output. So every x has one unique y. I'm going to write unique. So if you have a Venn diagram, all functions are relations, but not every relation is a function. And we'll go through examples down here. The domain is called the x value. So the domain's all the x values, which are also called inputs or independent variables. The ranges are the y values or the outputs or the ins, any one of those, or the dependent variables. So down here, determine whether each relation is a function by a mapping. So I'm going to create a mapping of this. So what I do is I take my x values. First I'm going to write in and out. So what I do is I take my x values and I write them from least to greatest, and I don't repeat. So I'm going to write 11, 12, 13, and 20. Then I'll take my y values and I'm going to write them without repeating. So my least one is -2. I don't need to write -2 again. I have it twice. Don't repeat. Then I'm going to write -1 and 7. Then I'm going to do a mapping, which is I'm going to show the relationship. So I write that 11 maps onto -2, 12 maps onto -1, 13 maps onto -2, and 20 goes with 7. So to see if this is a function or not, what you're looking at is, does each of these x's have a unique y value? Does 11 only go with -2? Yeah, 11 only goes with -2. 11 doesn't go to two different numbers. So analogy you can think about is, does each airplane go to one airport? You could not have one airplane go to two different airports at the same time. But you could have two airplanes going to the same airport. So this is a function because each x has one unique y. Or each airplane is going to a different airport. Okay, B. Now I'm going to draw a mapping of this. So I'm going to look at my x values, my inputs or my domains. I'm going to write them in order from least to greatest. I don't need to write -2 again because I don't need to repeat it. -2, -1, 6. And then my y values are, my ranges are -1, 0, 1, 3. So I'm going to connect -2 to -1, -1 to 0, 6 to 3, and -2 to 1. So is this one a function? If I look at this -2, it's going to two different ranges or two different y values. This cannot happen if it's not a function. So I wrote no, it's not a function. -2 has two y values. So if you think about an airplane analogy, this -2, this airplane can't be at two different airports. So another way we can look at functions is evaluating them. So to evaluate for domain means let this be your x values. These are your x values. So you're going to literally plug in -3 into the rule opposite x squared and see what you get out. So if you plug in -3, it's going to be f of -3. Oh, I should probably explain this notation. This means the same thing as y, or the output, but what you're going to do is you're going to plug in these numbers for x. So when you see an x, you're going to replace it with your input value. So this is going to be f of -3. We read it as f of -3 equals opposite -3 squared. Remember, if you have a negative, you need to put it in parentheses. So when I plug in -3, I need to do order of operations, so it's -3 squared, which is +9, and the opposite of it, which is -9. So I'm going to plug in -2 next. So it's f of -2 equals the opposite of -2 squared. So -2 squared is 4, and the opposite of 4 is -4. Now I'm going to plug in 0. So f of 0 equals opposite of 0 squared, which is 0. Then I'm going to plug in 1. F of 1 equals the opposite of 1 squared. So I do 1 squared first, which is +1, and take the opposite of it. So f of 1 is -1. So to evaluate for the domain means you need to plug these numbers in for x into your function. So let's try another one. Let g of x be the absolute value of 2x plus 1. Find the range for the domain of x, of these x's. Find the range means find the y values, find the outputs. So we're going to do the same thing. We're going to plug in -1, 2, and 4. So I'm going to do g of x equals the absolute value of 2 times -1 plus 1. I got sloppy, but 2 times -1 plus 1. So the absolute value of 2 times -1 is -2 plus 1 is the absolute value of -1, which is 1. So when I plug in -1, I get the absolute value of -1, which is 1. Now I'm going to do g of 2. So it's absolute value of 2 times 2 plus 1. Well, that's 5. Now I'm going to plug in 4. So it's g of 4. So g of 4 equals the absolute value of 2 times 4 plus 1. So if I plug in 4, I get out 9. So this question, letter B, was the same. If you have to evaluate the domain for these given numbers, it's the same as find the range for these given numbers. Okay, now second part. So evaluate f of 2 plus g of 3. So since I'm not given a function for f and g, I'm just going to look up here because that's what we're referring to. So f of 2 is equal to the opposite of -2 squared. So f of 2 is equal to 4 and the opposite of 4, so it's -4. Now g of 3 is equal to the absolute value of 2 times 3 plus 1. So g of 3 is equal to 7. So what this is just asking me to do is add f of 2, which is -4, plus g of 3, which is 7. So -4 plus 7 is 3. Same thing with over here. I'm going to do g of 1 minus g of 2. So first I'm going to do g of 1. So g of 1 is equal to the absolute value of 2 times 1 plus 1, which is 3. Oops, 3. And then I do g of 2. So g of 2 is equal to 2 times 2 plus 1, which is 5. So g of 1 minus g of 2 is 3 minus 5, which is negative 2. On the previous page, we looked at what made a function if you're given a set of ordered pairs or a mapping. But if you just have a graph, to figure out if it's a function, what you want to use is what's called a vertical line test. So in a vertical line test, what you do is you look at the function. So here's an example. Or you look at the relation, and to figure out if it's a function, you draw, if you drew an infinite number of vertical lines, would those vertical lines ever cross this twice? It doesn't. So this one is yes, a function. So with this parabola, it's called a parabola. If it's a quadratic like this, it makes a U. If I draw an infinite number of vertical lines, I never cross twice. So this one is yes, a function as well. But if I make a sideways U and I draw vertical lines, it's crossing twice. So this would not be a function. This one is a function. This one is a function. But I'm going to show down here how a couple of these are not, or some of these are not functions. See? So if these are not functions, because if you drew vertical lines, you would have the same x, but it'd have two different y values. A circle is not a function because this has the same x, but two different y values, and for it to be a function, it has to have unique y value. So this one isn't a function, and this one. So a couple more examples would be, this is not a function, but this is.